Hi, so today in this video I was asked to cover chapter 4.1, problem 33 and 37, and this is talking about graphing exponential functions. Let me just change my pen really quick. So 33 said, well, the instructions say graph the function not by plotting points, but by starting from graphs in figure 2, state the domain, range, and asymptote. I do not have figure 2 with me, and it's not apparent where it is in the homework. It's just a few pages before. Excuse me. But I'll just graph normally. We want to state the domain, range, and asymptote. So let me first, so we have y equals, well, hold on, let me make the background white. Okay, we've got y is equal to, 5 to the negative x plus 1. And we want to graph this. So first, let me draw a little graph. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. Okay, so the parent graph of 5 to the x is like so. We always start at 0, 1, and then we go up 5, so 1, 2, 3, 4, 5, over 1, and then 1/5. So our parent graph is going to look something like this. But we have a few transformations applied. First, we've got a negative x up here. Now, if you remember from our transformations unit, when we have a negative right next to the x, in front of the x being multiplied, what is going to happen is it's going to do a flip. So it's going to flip, but it's going to only be affecting our x's, not our y's. So what's going to happen is, let me duplicate this and do a horizontal flip. It will look something like this instead. Let me change the colors. So now we have a green graph, but it's also being moved up 1. So let's just take this and scooch it up 1. So that is simple enough. When we are graphing exponential functions, we always have a point at negative 1, 1 over our base, for our parent functions at least, and then 0, 1, and then 1, our base. And by base, what I mean is the one that's directly attached to the exponent, so like this 5 in this case. Yes, hopefully that makes sense. The asymptote would also move up 1, because the asymptote is going to be just at y equals 0, but when we're moving up 1, so does the asymptote. So we'll have an asymptote at y equals 1. Our domain will be negative infinity to positive infinity, because it's going on forever. And then our range will be equal to, our smallest point is going to be almost 1, but not quite, and then to positive infinity. So this would be the answer for 33. For 32, let me get rid of this. 37, we have 2 of x minus 4 plus 1. And the good thing to start with would always just be to graph our parent function. Our parent function is 2 to the x. We can see because we've got this 2 right connected to our exponent. So we'll start at 0, 1, go up 1 over 2, over 1, up 2, and then over to the negative 1, 1 over our base, which in this case is 1/2. So this is our parent function, give or take. We also have an asymptote at y equals 0. So this one, we have a transformation here that is the minus 4. And since it's super close to the x, it behaves in a way that we kind of don't expect. So it's actually going to be going to the right 4, not left. So 1, 2, 3, 4. And then we're going up 1, so it'll look something like this instead. Well, we were like this. Hold on. I lost myself. 1, 2, 3, 4, up 1. So something like this. Let me recolor this graph. Let me get rid of this. So this green graph is our correct graph. Yeah, it's fairly simple if you know how to graph the parent function of your exponential graph, and then it's just normal transformations. If you have any other questions, let me know, and I will answer them as soon as I can. Have a good one.